Okay, so next talk about TwinCAT OPC UA, and of course we are not making a pure product presentation here, so I selected the topic to present to you the SOA-PLC and our experiences we have already. So we have some success stories in the end of the talk. I will try to go through it, and it should be a summary of the technical aspects from a PLC point of view to our customers for getting the bridge between the OPC UA connection and connectivity we have since almost 10 years now, and the upcoming and raising Industry 4.0 communication we will have in the future, and the changes we have there. So very at the beginning, for those of you who haven't heard about Beckhoff too much, we are located in more or less the center of Germany. Well, no, not exactly the center, but close enough. Of Germany, we are making about 680 million sales worldwide currently, and are growing. Looks very good this year again. There are about 3,500 people working for Beckhoff worldwide. What we are doing more than OPC UA, right? So our main business is producing hardware for doing industry automation. So either the IPC, which includes the panels, the IPC for the DIN rails, or for the cabinets. We are making software, of course, so OPC UA connection is one of the parts of it. But we are, of course, have invented the EtherCAT system and all the bus modules which we are producing there. And that's the last point to mention, is the motion part. So we are having motion components too. All our controllers, and that's one of the foundations for the OPC UA implementation, are founded on Microsoft operating systems, so back to DOS and Windows NT, and now of course we have Windows 10 controllers equipped with our real-time software PLC equipment, so the TwinCAT system, which provides you with a PLC and C++ interface in the real time. And then of course the question is, well, I've defined my variables within my program, I would like to have that accessible as OPC UA, so acting as a server, or retrieving data, querying data from somewhere else, so being a client there. That's the bridge we are talking about in the next minutes. We have a commitment to OPC UA since 1989, so back quite plenty of years. And we have, had the first OPC UA server embedded into a PLC. We have certified our product as a second vendor in Germany and worldwide, and have also implemented as a very first vendor the OPC UA client function blocks of the PLC Open, which we'll see later on. In 2014 we had this OPC UA server, which we're calling OPC UA SOA capabilities, which means we are talking about models, about providing methods and consuming methods on the OPC UA spec level. The commitment is quite more than only implementing the different components. It's also that we are providing or have the chair of the working group of the PLC Open with the OPC Foundation. We have with Stefan Hoppe, who is on our payroll, the president of OPC Europe, and he was elected as a vice president, as you've heard before, in 2015. So okay, coming back from Beckhoff and the journey to the business, we come back to the IoT and Industry 4.0. What is the difference in this terminology? We're trying to differentiate here. The terms are mixed somewhat, but mostly if we are talking about IoT, we are talking about small devices acting we could say as an agent, and they are pushing data, and we don't really care about the data on the wire, right? So it's not what OPC UA is. IoT is more about having all the pieces selected together and all pushing the data upwards. Of course, security is a good requirement there. The data is simply transported, and the the interoperability is not that important. All these guys here sitting here more or less independent in the Internet of Things and pushing the data upwards, but there is no interconnection. We see that more this Industry 4.0 is driving the horizontal communication there, as well as vertical communication. But also, which is important for the future, is that we have discovery capabilities. So PLC needs, as an OPC UA member of the whole network, needs to be able to discover other devices which are available either via a broker or a discovery mechanism or on the network level itself. Modeling, information modeling, so not data modeling, but information, having that I know my data point is a temperature and I know this temperature was measured in a whatever machine on a concrete place, and I could react on the temperature at this place. This is one of the important points, and this is where OPC UA in the industry is really having its uniqueness and its benefits. Of course, the scalability is important in Industry 4.0 terms, so we are acting as very small PLCs, or could downsize this. You heard that we have OPC UA in silicon for very small devices, but this goes up, of course, to many core systems for driving either machines or being established as a cloud within the cloud system itself. Again, well, security is of course a topic everywhere currently, so not only encryption on the wire, but also authentication or signing of messages and commands which are flying around. So what are the communication requirements for these kind of intelligent devices? Today, we have more this top-down approach. So in established machines, we have normally the PLC, the machine is acting as a server, so it sits there and is just providing access to its variables in the end of the program, or part of the variables of the program. But in the next generation, we think that there's more bidirectional communication between different controllers. They're acting as intelligent I/O sensors, and, for example, intelligent cameras. And the other one is the content. So the first one was the direction, and the second one is the content. So what is transferred actually? There are currently mutable converters all the way. So we have electrical signals. These need to be converted to at least data, then the data. So a simple number needs to be converted to an information. And this information, then this data together with the metadata needs to be transported. And this gets even more important in the cloud scenario, because on a machine, if I see there's a value and I see the name of the value, I could conclude from a human being, I could conclude which temperature is measured. But on the cloud system, 2 years after, if I have a storage system, I'm not able to see, well, what is that origin from, coming from, how to interpret this data. So it's important to annotate the data when it's aggregated or before it's aggregated. So we see that's more service to service interaction than rather just sending binary bits and bytes forth and back. And that comes where OPC UA has a perfect foundation, let's say. So we have, of course, data modeling and communication. We have, and this is growing and quite important really, the collaboration to all of these other standards and the integration of them, which is coming up here. One problem I see now is, which is arising, especially when we are looking at the drafts of the VDMA working groups, that we do not have currently we do not have a database of common data types. So if I have an IP address and I would like to represent this as a OPC UA information point, then then you need to start on top of the OPC UA base data types. There's nothing which is helping you. So we need more of these companion specification models which are just providing the base data types, enhanced data types, so like an IP address. Otherwise, we would end up in having an IP address defined in the whole range of companion specifications, slightly different, and all the types are not matching to each other, and we have converters again and again and again in the future. So this might be a demand we need to address in the future. So back to the SOA-PLC, what we understand there is that we have this, in the middle we have an operating system and a PLC, and this is not important anymore who is producing that, at least if we are looking from outside. We have data services, engineering services, monitoring, administration, and so on. We have specific services for acting with the system. Of course, if you're transferring files, the format, and so on, everything which is not represented in OPC UA is important, but providing these services and using them, it's independent of the operating system and the runtime system, which is driving the real-time in the core of the system. Around these services, we have these different models, and there we will have a more detailed look in the next minutes. The outer circle is the transport, so the simple transfer from one target to the other target, which might need to be encrypted and signed and so on. We heard that a couple of times this day. So yes, models. There are 3 of them from our point, so 3 types of models. The first one is the standardized model, so the companion specification, so which are cross-vendor acknowledged that they are accepted, more or less of course. The other one, we think there will always be vendor-specific enhancements because the different vendors would like to have unique features, right? And you need to, for having innovations, you need to have the possibility, and luckily OPC UA provides us with just having the ability to provide another model in addition. So we could provide a companion specification which is accepted in a domain, and additionally provide additional features for our controllers or for our machines if we are talking from the point of our customers. And the customers from their self would like to add, of course, additional models, we believe. Okay, let's shortly go to the standardized models we see as the most important for a PLC point of view. Mostly established and used might be the ones from the PLC Open, but also from on the MES level or the Auto ID is getting more and more attention and might raise in the next years. And I believe the right point our OPC UA has won if our customers, so the machine builders, do not even recognize that OPC UA is in there. If they are connecting their barcode readers or whatever is representing and talking OPC UA and they have a sticker on it, this is compliant with the specification. They simply plug it in, put in an IP address, and it works. Then OPC UA has won and has succeeded in this demand. Yeah, there are plenty of them and efforts. We heard about the VDMA, and at the end, this general purpose device, these devices from Beckhoff are general purpose devices. They are running Windows and they could do anything. They could even be used as a working station if you would like to. But from the OPC UA point of view, together with the standardized models, they could act as a smart meter. So you won't recognize, if you're going from outside to the device, to your machinery, you won't recognize if there is a controller inside or a silicon representation. You just see, I am a smart meter, and it's independent if it's the PLC is from the vendor A or B. Or it could be an RFID device, or it could be a PLC. If you would like to have the knowledge outside, then you are using the 61131 mapping of the PLC Open to represent your PLC in a PLC way in the OPC UA world. Yeah, having a look at the at the mapping, we see that we have different representations. So the programming is done in the engineering environment, and then this mapping is applied from the PLC Open to see the correct namespace which is built out of the programming. So if two programmers are programming it in their engineering environment, the PLC Open will take care that the outcome of the namespace is comparable, even when the binary execution on the target is completely different and might be of different purposes and different compilers, languages, and so on and so on. But beside the fact that we have different entry points, the semantically identical objects are defined by the PLC Open. So you will find in function block boiler 1, you have seen that a couple of times in the last years, I believe. This is the communication principle behind that. So we could have vertical and horizontal communication. We are not only acting as a server providing access to the function blocks, but we could also do that on the client base. So if we are connecting to a device and we know there should be a function blocks FB boiler, then we could search for it and use it in the way that it was defined in a companion specification, for example. On the client side, we have these function blocks from the PLC Open, which are developed in a group. So read and write function block and a method call function block, which will come into place if we are talking about service communication, which is meant to be a couple of method invocations there. Okay, so this was a small overview of the standardized models we have in the PLC on the PLC level. The Beckhoff world has as another one or two models currently we are providing. The first one is the IPC device manager UA interface, where you have access to the heat of the CPU, to the load of the CPU, of the memory, and so on and so on. There simply is no companion specification for that, so we need to invent our own there. And it's partly used by our customers. They are happy with that, but sometimes maybe some CPU vendor or so would define such a companion specification, and then we could additionally support that. The second one is the maintenance of the PLC could be done via the file transfer. File transfer itself is defined in the UA specification, and we have implemented this into our PLC, so we are able to receive and transfer files, and we'll see that these are this functionality could be used, for example, to update the PLC code. But that is again Beckhoff specific. Our Beckhoff controllers have their PLC program represented as a file on the file system, so on the SD card or whatever we have. That could be that is Beckhoff specific and not part of a companion specification, so it's not independent of it. Okay, and customer models, of course, could be used, could be defined by our customers simply by applying a small attribute next to the codes for having methods be callable via UA. So it's just one line of code for saying the UA firmware, please provide that method as UA call, and then you could call it with any client which is able to call that. And this service call is there outputted. So in the end, these method calls are now replacing the traditional MES and shop floor communication, right? So we have normally this 5-way at least handshake where we're reading and writing bits and bytes, and instead we could just make one method call as a service invocation, and we are consistently transferring the data and getting a return value back, so we know as a MES system if we are calling a method on the PLC directly what's going on there. The PLC could immediately react. I'm busy, I can't produce anything for you MES system, and reject the demand or accept the demand. Short overview of our success stories we have already. So The first one is the IoT in decentralized intelligent equipment, which is a joint water and wastewater authority in Vogtland. It's the area in Germany. And there we had the scenario where we have different pumps and valves and boilers, and they are communicating to each other for doing something like a load balancing between these different pump stations. So one pump station could monitor another pump station and say, okay, this seems to have no water anymore, I take over, or a pump station could actively call a method on the other plant for handing over and saying, please take over the filling of the elevated reservoir. And all this is done within a closed intranet network. So, but it's already a board-wide area which was covered with that and quite some years ago. So it's quite impressive that we have done that and succeeded. Customers succeeded there even before we are known with the word of a cloud. The second one is from Ulster. Within their production, they've done the connection directly from the SAP system to the Beckhoff controllers as in SOA call, so a method invocation, a couple of method invocations, for fulfilling their shop floor, connecting their shop floor to the top floor in the SAP system. They had the demand to really quickly connect new machines. So within 30 minutes, they wanted to have a new module, we could say, up and running. And this was done in a way, well like we would like to have it with our companion specification. It's only the address which needs to be added. Everything else is predefined and fixed. So they have done one of these customer-defined, internally defined communication protocols for the companion specification for them. They had some demands for security also, so they have this certificate exchange and so on established there. The other one is the Regio IT project, which we have here in more details. It's also based on the SOA-PLC principle. In kindergartens and so on, we have installed controllers, so very small cabinets, calling methods, pumping up their values into a database, into a central database per city, so per customer. And then Regio IT is providing a web interface for doing data analysis, raising alarms if there is a water leak detected within the kindergartens or so on. And the last success story is about the Grundfos. They had an interesting project within a student house. They have 160 Beckhoff embedded controllers placed with 3,000 data points. They're aggregating that to one big IPC and then using, so this is internally done by OPC UA. And externally, they are pumping it up into the IoT hub using the AMQP. So this is PC is more or less acting as a gateway. So from the OPC UA world to the cloud world, to the world there. So this is a small overview of our different products there. We have different controller types, of course. They are talking all these three kinds of protocols to the cloud, and you could choose whatever you would like to. The other protocols, MQTT and AMQP, without any extension of OPC UA, are more or less useless, I believe, because they would pump byte strings to the cloud, and nobody knows in 10 years what's in there. So we need additional information in MQTT or AMQP, and this is what PubSub OPC UA is about. So this would be the most important enhancement we will have on the first, on the Industry 4.0 communication on the one hand, but also I believe on the UDP communication within a factory and within the controller level itself. Thank you.
Okay, thank you very much, long presentation again, but very interesting cases and real use cases from the real world. So it's always good to hear about those. Do we have questions for Henning? Okay, so we move to the last presentation.